Alrighty, everyone. I think we're ready to get started. Good to meet you all. Are you ready for the most exciting, potentially, conference presentation of the day? Here's why it might be exciting. I'm really bad about edges, and my depth perception is terrible, so I have a tendency to fall right off these stages. Get your cameras ready. It's going to be fantastic. Alrighty, everyone. Well, we're going to start talking today about vulnerability-centric penetration testing. What that effectively means is we're going to be talking about pen testing, but we're going to look at it from the perspective of vulnerability specifically to guide our way to finding exploitation. Just a quick thing about me real quick before we dive in. My old me, or who I used to be, list versus what I do now, has very much truncated and shrunk, but I used to work at Black Hills here in Deadwood, and I also used to work with counter-hack challenges doing net wars. Anyone here played net wars before? Yeah, fun stuff. I also used to be in the Air Force. I was a SAN instructor once upon a time. I've left that all behind me, and I run a cybersecurity firm called Open Security now. But at the end of the day, and as it relates to this presentation, I am a communist. Yes, I am an Infosec communist, and that means open source, MIT licensed. Let's go. In any case, let's dive right in. What is the dealio with penetration testing in 2024? Specifically, what are our primary issues and challenges that we're encountering? I run a penetration testing company, and so these issues come up all the time for me and my team. And it seems like, from the perspective of penetration testing specifically, things have started to get a lot more difficult. And it's not just that they've gotten more difficult for us as the offensive security personnel, but it's gotten a lot more difficult for us to produce the same level of value that we perhaps used to in the same amount of time that we did in the past. And there are some usual suspects here. And these are good things, by the way. EDR, endpoint protection, absolutely. CrowdStrike has very much lowered the barrier to entry to being some reasonable level of secure, and also they have lowered the barrier to entry to being some reasonable level of completely out of power and utilization of your systems. Anybody here fly with Delta? Oh yeah, CrowdStrike Delta. Oops, that was not too great. But from a security perspective, CrowdStrike is really difficult for us to deal with as penetration testers. And I want to make something really clear here first. That doesn't mean that we shouldn't be worried about CrowdStrike. It doesn't mean from an offensive security perspective that it doesn't matter, but it does mean that it is changing the way that we do and think about penetration testing, and as a result, we can blame red teams for absolutely ruining everything for us. Yes. And what do I mean by red teams? I'm actually talking about red team tooling. Who here has ever used Cobalt Strike? I know we've got Fortra as a sponsor here in the building as well. Yeah, so Cobalt Strike, really, really commonly used tool. We'll look at some statistics. Wow, that's a word. Some statistics about Cobalt Strike and its use for nefarious purposes by adversaries doing exploitation, doing ransomware, and all of that kind of stuff. But for us on the blue but red side, so defensive security, but we're doing it from an offensive perspective, penetration testing, red teaming, we really often live by these tools. Now, to be fair, there is something to be said about whether or not we as penetration testers ought to be leveraging red team specific or red team focused tooling in order to accomplish our objectives. But if we really think about the problems that we're encountering doing penetration testing today, or at least succeeding at penetration testing today, some of these tools can be rather valuable. Let me define that level of success for you here real quickly. Is succeeding at penetration testing getting domain admin? No, it is absolutely not about getting domain admin. It is about presenting value to the organization. It is about finding vulnerabilities that an adversary might exploit in the future and understanding what the impact of that exploitation is going to be before the adversary gets there. And then hopefully we get some remediation. That doesn't happen as often as we would like, but hopefully we're going to get some of that. In the case of red teaming, though, these concerns are absolutely not the same. What are we testing if we're doing a red team? The blue team, it's in the name. As a red team, we have two goals from a testing-based perspective. The first one is we want to test blue team controls that might be stopping us from getting access to things that we might want to have. And the other side of that is blue team training. Do they know what they're doing? Heck, as a red teamer, can I take blue team tools away? One of my favorite techniques to do as a red teamer is I will go into the ARP cache or even the DNS cache, and I will absolutely blacklist the heck out of Endgame, CrowdStrike, all of those servers. And when a blue team can't use their EDR product, they lose their ever-living minds. But as a penetration tester, do I care about this? No, my scope does not allow for it. As a red teamer, I don't really need to prove exploitation. I don't really need to exploit my way around the environment and show you all of the different stories by which an attacker might replicate this attack and achieve that impact on your environment. As a red team, I don't really care about this. I care about the resiliency of your blue team. And so if we're looking at a penetration test and we're saying you need to do all of this in a smaller test, we're in for a world of hurt. And so if we look at what penetration testers have started to do as a result of this kind of massive change in the way that we see offensive operations, is we started to live off of the land a whole lot more. Things like using built-in SSH, using Chisel, using all kinds of utilities that are for IT professionals as opposed to for hacksaws. But it didn't always used to be this way. You see, once upon a time, in a world far, far away, we had this tool called Metasploit. Has anyone here used Metasploit before? Has anyone here used Metasploit this year? I've got some hands still. Fantastic, fantastic. Metasploit is an outstanding tool. It is really, really awesome. A lot of folks tend to think it's dated these days. They're not wrong, but it's not as dated as you might think. There's a bigger thing to understand here with Metasploit, though. This is not a conference presentation all about how to use the basics of Metasploit, though we do have a Metasploit demo. Instead, it's about understanding why Metasploit was so dang good for penetration testers, not red teamers, but for penetration testers. And if you look at Metasploit from a breakdown perspective, as you see here, it is actually a framework of lots of different modules, plugins, tools, capabilities, scanners, auxiliary modules, all of that stuff. But it has one fundamental objective: find a vulnerability and exploit it. That's it. That's the entire purpose of Metasploit. And after you've exploited that vulnerability, let's say remotely, externally, now you have access to a local machine, and there might be more vulnerabilities for, let's say, privilege escalation. Let's find those, let's exploit those. Maybe we're using an agent in this case, maybe an interpreter, but that's the idea of Metasploit. It's focused on the vulnerability, and it's focused on what we can achieve because that vulnerability exists on the given system. What about Cobalt Strike? You see, one of the more interesting things, in my opinion, on Metasploit is that with Metasploit, especially in the more modern tense, let's say the last 10 years, you almost exclusively find yourself getting code execution, so exploitation, outside of the Metasploit framework itself, and then you might use like a multi-handler to trigger an interpreter or something of this sort, right? If we look at red team C2 tooling, it is almost exclusively based around this premise. It does not care about the vulnerability. Absolutely doesn't. Doesn't even know that vulnerabilities as a concept or idea exist. It says, get code execution outside of this tool, and then bring that into the tool, and we'll do operations next. I think this is a really important thing for us to understand when we differentiate Metasploit versus other command and control utilities, because while Metasploit does have C2 tools, right? Agents, backdoors, interpreters, the most common one, right? That's not what it's all about. Metasploit is about the vulnerability and what that vulnerability could do to your environment. So what is kind of the state of Metasploit today? I, in fact, put a Twitter post up about a year ago now, and I said, you know, real talk, how often do we actually fire up Metasploit these days? And there were about two different categories of people's opinions. The first one was like, boomer tools, get out of here. And you know, a bit more of every nevuary, maybe who is this anyway? ZenMap the world, dude, forget about Metasploit. And this is a big set of opinions that we do have in cybersecurity at the moment, as for better or for worse. But there are reasons for this, right? The community has transitioned. One of the things that I found most interesting, though, is the second set of opinions were a little bit different. So first off, well, I should probably put these into three. Like, nah, I never use Metasploit. Hey, there's a vulnerability that comes out, and the exploit for it only exists in Metasploit. So whenever this comes out, you know, once or twice per year, I'll spin that sucker up, fire off the exploit, get some code execution, hack the planet, etc. And I would say that for most of us, this is probably the category of Metasploit usage that we fall into these days. If you're doing regular penetration testing, particularly network penetration testing, you likely do, in fact, sometimes use Metasploit. But maybe you don't enjoy the experience. Maybe you don't know it quite as well as some other folks do. Because this is the third take that we tend to see with Metasploit. We see people say, yes, every single pen test, I use Metasploit for the database. Nah, I don't care about the exploits. I definitely don't care about Interpreter because AVG is going to stomp on that, let alone CrowdStrike. But that database, it makes me so much more efficient where I'm operating along large data sets. Maybe I'm doing a pen test against an organization that has 10,000 endpoints or even 100,000 endpoints. Gee willikers, how do we figure out where we should be spending our time? And this is a place that Metasploit shines. The reason Metasploit shines here is because Metasploit is, by its very definition, vulnerability-centric. And so for penetration testers, this is outstanding. Unfortunately, a lot of the things that we used to use Metasploit for are not this. And therefore, we see a lot less usage of Metasploit these days than we did in the past. The big thing that we have to understand here is that there's a direct misunderstanding about what the purposes is of our tools. Like if we look at Metasploit, Metasploit was for decades in cybersecurity the biggest hammer on the planet. It wasn't just a hammer, it was a jackhammer. Everything was a nail, and all those nails were standing up at right angles, and we smacked those suckers down with Metasploit. Thousands and thousands of contributors to this project. I can't even begin to describe the number of people who learned Ruby because of Metasploit. This was our primary tool. And then this guy came around called Raphael Mudge. Anyone know Rafi? Yeah, I used to work with him in the Air Force, and he created this tool called Armitage. Anyone used that before? I find Armitage to be a really useful utility to teach people about networking and pivoting, routing, those kinds of things. But Armitage essentially is a UI that makes Metasploit, in a lot of ways, easier and more simple to use. After Armitage, he created Cobalt Strike. And Cobalt Strike did this thing where they dropped the Metasploit project as part of the tool itself. And I had words with Rafi at the time. He's like, this is crazy. Why would you do that? He was right. Because it turns out that if you're doing a red team, you don't care about vulnerabilities, and you shouldn't. If you do, you are wrong. Maybe that shows up in your report, but it should be an afterthought. We don't care about vulnerabilities, we care about the blue team. And Cobalt Strike does too. Now, if we actually look at the utilization of these C2 utilities, these attack offensive tools, in the criminal world, if you will, we do still see quite a lot of utilization of Meterpreter. In fact, I do a little bit of incident response myself as well, and I'll tell you right now that I tend to see Meterpreter far more frequently in incident response than I see it in penetration testing. And that is because adversaries, and this is very traditional, tend to upgrade a little bit more slowly than we do on the penetration testing and the for-profit information security side of the field. And so as a result, there's still quite a lot of Meterpreter there. And I'm even going to give you a demonstration here in just a moment of exactly how that might come about. But at the end of the day, Cobalt Strike is the #1 utility we see from adversary utilization in order to compromise environments and then deliver ransomware, if you will. 3 core problems we have here as pen testers: the alignment of those tools to the work that we do, the alignment to the defenses that blue teams put in place, and how those might conflict with our penetration testing objectives, and finally, our ability to operate efficiently. I think that last one and the Metasploit database really go hand in hand. But I do want to take a moment here to talk about defense alignment. You see, one of the biggest problems that I'm finding at Open Security, that's my pen testing firm, at the moment, is that we might sell someone a pen test, and yet we have to deal with a lot of the red team focused stuff to even get started, to get jiving on that penetration test itself. You see, Metasploit, Meterpreter, is at the top of this list still. And if we wanted to leverage that as penetration testers, suddenly we're saying all of the defensive controls that we don't really care about too much as pen testers, we need to bypass those to even start on the job and the work effort that we're doing today. And this is one of the primary reasons why we see penetration testing moving very heavily to living off the land. So things like terminal services, remote desktop, MS-SQL with XP command shell, foreshadowing, all of these kinds of tools and techniques that don't flag malware at all, or don't flag as malware at all, because they are legitimate access tooling. And so if we look at Cobalt Strike, yes, we see a lot of exploitation related to it all over the domain. I'll do a quick example here with Microsoft SQL Server. I find that if I'm showing up for an incident response, some of the most common ways the adversaries have gotten access is through remote desktop. MS-SQL is a really, really big bug. And I say the whole thing as a bug because some of the feature sets that it has are absolutely crazy. Like if you have a SQL administrator, that's the SA user account on MS-SQL, you can do straight system level execution, no privilege escalation required on those systems where it might be installed. If I'm an attacker, this is money. This is absolutely money, and I have showed up for quite a few incident responses that started with this level of exploitation. let's actually go ahead and walk through this here real quick, and we'll take a look at how this might look in a traditional sense with Metasploit. Most of this is not particularly novel information, though we're using Metasploit 6.4 here, which was released this March. I think a lot of people are sleeping on Metasploit. In fact, I was sleeping on Metasploit. The 6.4 release is actually really nice. It's really, really good. To be fair, I don't necessarily recommend Meterpreter with it because, of this slide right here, but the framework itself is a lot more smooth, if you will, than I've ever seen it in the past. All right, let's go dive into our first demo and see how many failures we're going to achieve. I did sacrifice a chicken, I swear. All right, so this is Metasploit here, and there are a number of modules. In the case of Metasploit, though, we can use any module from a different category that we would like to. In this case, I'm going to be using an auxiliary module, a scanner specifically, and we're looking at MS-SQL. So let's go ahead and trigger this one up here, and I'm going to use login. Alrighty. In addition to this, I'm going to kick off a really quick Nmap scan against a remote target, make sure that it is live, and also to make sure that the ports that we're looking for are in fact there. And this is very traditional penetration testing, right? We're looking for the art of the possible, we're looking for what is there, and then we're looking for what opportunities might we have to exploit these things. In this case, we've got MS-RPC, and we have MS-SQL. There could be a vulnerability that could give us direct exploitation for this as a bug. But if these are all fully patched, what other vulnerabilities might exist? And today, the most common way that adversaries will use these systems to get access to environments is absolutely with passwords, bad passwords. And this Metasploit module is very good at identifying that vulnerability. Let's go ahead and take a look at the options here real quick. So we're looking at the options now for the MS-SQL login module inside of Metasploit version 6.4, and it's just basically telling us all of the information that it would like to have in order to do this successfully. In order to make the demo a little bit more efficient, I did actually pre-populate this information. Let me just double check that it's there. Yes, that is my SQL password. Oh yes. Now that might seem a little contrived to you, but I was just doing a voice-based phishing engagement last week for a bank, and I called their help desk, and the help desk reset their chief cybersecurity engineer's password to password 12345 exclamation point with a capital P because complexity. Yeah, there was no authentication required for that. It just worked. And this stuff works all the time. Anyone here familiar with the MGM breach? So the MGM breach was an intrusion set called Scattered Spider, what I just kind of talked you through from last week, voice-based phishing. That is exactly what they did. Because if you got a voice like this, everyone believes you're their friend, right? Let me reset that password for you, my guy. I got you. I got you. And so if we've gotten that level of exploitation, can we trigger this vulnerability? And the answer, of course, is yes. Let's get that done. Fabulous. Now this, if you haven't used Metasploit in a little while, might look just ever so slightly different. And this is one of the interesting things that I find in version 6.4 of Metasploit. Specifically, it allows you to create individual sessions, and there is a new setting for this that I also set. Give me one second, I'll pull this up real quick. There it is. Create session equals true. So if you set this session or this setting inside of Metasploit, which is a brand new one, it'll kind of background create the existence of a session, and then you can interact with that and do whatever additional modules you would like to against the existing session, as opposed to having to re-exploit. And this is a very traditional problem that you would have seen in Metasploit in the past, is, I did MS-SQL logon, I didn't have the right payload configured that I wanted in order to do the next step. So I have to exploit it again, and if that exploit was, let's say, probabilistic, maybe causes blue screens, maybe on a 13% basis, then suddenly I'm causing potentially damage to the organization's environment. I might be causing outages. In Metasploit 6.4, they do have this pretty well sorted. I'm really impressed with this setting. Let's interact with that session, shall we? So we can list out our sessions here, and then we can just do attack I to interact with one, like so. And this is where things start to get a little interesting. So if you look at Metasploit, and this is again a 6.4 feature, it'll actually tell you specifically what the other modules that are in the entire framework itself that are able to interact with the existing session. And that includes things like direct execution of arbitrary commands, or even using specific payloads that exist in the framework. Really, really nice. I'm a big fan. In this case, though, we're actually on the system, and we can run any of these commands if we would like to interact with the SQL database, run arbitrary queries, do code execution on the system, move laterally, dump passwords. In fact, we can even just directly steal the hashes from MS SQL, all kinds of stuff. And the reason I wanted to go through this is because this is what a typical breach often looks like for an adversary. They get the password through some fashion. Maybe it's credential stuffing, breach data. Ask Colonial Pipeline about that one. Metasploit module next. MGM, resetting the passwords from the help desk. Metasploit next. Because you see, Metasploit isn't just a command and control framework. In fact, it's not really a command and control framework at all. It is an access framework. It is all about understanding all of the different protocols out there that you could possibly imagine, and then determining how we can use the way it's designed to be used for access. In this case, I used MS SQL, but one of the more common ones that you'll see are SMB. We could do the exact same procedures that we just walked through with MS SQL, with SMB, with RDP, with all of these different services that adversaries constantly use in order to exploit our environments directly within our primary vulnerability-centric framework. This is amazing. This is absolutely awesome. Unfortunately, what do you do with that exploitation? You might have noticed I didn't actually pop a shell on this box. Specifically, I didn't pop a interpreter because it's hard to get those to run these days. It really can be. You see, the problem with Metasploit isn't Metasploit in a lot of ways. The problem with Metasploit is actually Meterpreter. But you see, Meterpreter isn't really a command and control tool. Yes, it is a remote access tool. It absolutely is. But if you look at the way that Meterpreter operates, it's just about getting it done. It says, let's do a straight socket connection, or you could do an HTTP Meterpreter. You could totally do something like that. That's stateless, it's a little bit better. But if you want to arbitrarily change things like jitter time so the callbacks don't happen at the same interval, or change the callback ratio, any of those kind of things, that's just not what Meterpreter is designed to do. And it shouldn't be designed to do those things either. You see, as a pen tester, I do not care about jitter, period. I just don't care. And so if you have all of those features built into your tool, all that does to me is tell me CrowdStrike's job is a lot easier because you've got a lot of complexity in your backdoor, and that backdoor is being used rapidly by adversaries out there, and now suddenly my tooling is less valuable because of all of those problems. So the problem here isn't Metasploit necessarily, it's what happens next when you're using Metasploit. Now, I do want to say something real quick about Meterpreter. Meterpreter is the best, most awesome backdoor that I have seen outside of US government operations with zero exceptions. If you are writing yourself a backdoor on your own and you want to use, let's say, Win32 API, C++ calls directly, don't do the research. Don't go to Microsoft MSDN. Go to Meterpreter. Steal their code. It is awesome. Meterpreter is absolutely bonkers good, but it's not a C2 tool, even though in the industry, we see it used that way all the time. Alrighty, so that didn't really feel like a vulnerability, did it? We just logged into MS SQL and we had everything. Well, it kind of is, though. I believe that we have a bit of a problem in the industry, particularly around penetration testing and vulnerability assessment when it comes to understanding what a vulnerability really is. You see, we look at something like this and we say, you know what? It turns out that in 2023, there were over 40,000 individual CVEs released by NIST. Those are the vulnerabilities, right? Well, if that's our definition of vulnerability, guess what? This MS SQL stuff, that passes. We don't need to patch that. This is perfectly fine. Of course, it's not perfectly fine, right? You see, vulnerability managers are often a lot more focused on scanning, and those scanners are not tactical because those scanners are looking for misconfigurations, bugs, missing patches. They're looking for maybe software bill of materials-based scanning. They're not interested in exploitation per se. They are a little bit. They want to know if there are vulnerabilities associated, but they're not saying, hey, look, this vulnerability is one that matters to you as a penetration tester the most, because if you use it, you can rain shells down from the sky. That's not really how vulnerability management tends to work, though perhaps they could take some lessons. Is it a vulnerability? Absolutely it is. Are CVEs vulnerabilities too? I suppose so, but it turns out that the vast majority of vulnerabilities will never be exploited by anyone ever, with no exceptions. 40,000 CVEs in 2023. What intrusion set on the planet is learning 40,000 new techniques per annum? Are you crazy? That's not happening. That is absolutely not happening. So what really matters to us is understanding the real vulnerabilities, the vulnerabilities that are going to see actual exploitation by adversaries. What makes those up? So active exploitation in the wild, for example, That's a really good trigger. You know, if log4j is being exploited by a bundle of different named intrusion sets, maybe we should care about that one more than the latest TLS flaw that nobody exploits ever. Is it easy to exploit? This is really important. So when I said, you know, one intrusion set on the planet is adding 40,000 new techniques, what I'm really getting at here is it's hard to add techniques. That takes time. And if you are an adversary who does ransomware, let's say, you know, $10 million a pop in Bitcoin, of course, guess what this does to you if it's hard to exploit? It makes your billable rate go down. Yes, if I'm a criminal actor, I have a billable rate too, but guess what? My risk is a lot higher than a legitimate employee because I might get extradited, I might have to spend some time in jail, so you know what? My billable rate better be better than minimum wage. It better be sky high. And if my exploit is hard to pull off, or if it is probabilistic in nature, this is a direct contradiction to my primary objectives as a criminal actor. I would rather go somewhere else or use something else. And then finally, high damage potential. What does the exploit actually do? If the exploit just corrupts, memory in a process that is user land and you have to be user level access in order to do it, does it matter that you can do this? Like, yes, it is a vulnerability technically. Yes, it is a bug in the code, but does it really matter? What is the impact potential of this? And there are a couple nuances here. Take MS SQL as an example. Let's compare specifically Microsoft SQL Server versus MySQL, the open source pseudo equivalent, if you will. In the case of MySQL, does it allow within the framework itself, within the tool itself, for just direct code execution at the root level on operating systems? I have personally not encountered this. There are some things you can do if you get access to MySQL for sure, but when you conflate that with MS SQL, the damage potential is radically different. And this is what adversaries are looking for. How can we, given that there are 40,000 potentials and then more actual vulnerabilities on top of that, how can we narrow our scope here? CISA is a great place to start. The CISA has a known exploited vulnerabilities list. I imagine a fair number of folks here have heard about that. Have you ever heard of it? If you have not, you should definitely give it a look-see. This thing is awesome, but what I want to highlight is how much more awesome it has gotten over time. Check this out, for example. Is this vulnerability, this is one from 2024, known to be used in an active ransomware campaign? This is information, this is vulnerability intelligence, if you will, that CISA has not traditionally had as part of this framework, but they have it now. And they continuously update this nonstop, and they don't just update the new vulnerabilities, they update what it is that you're getting from a foundational level in the first place. This is amazing. But what if we want to do this faster? What if we need to be able to script within this data? Guess what? They have a full JSON library that we can also leverage directly. To be fair, NIST CV library also has one, and that is a direct API that you can query with like curl commands if you'd like to. But the point being, if we're looking at vulnerability data science, all of the major systems of record actually have the ability for us to programmatically interact with them. And this can be rather useful when we're doing penetration testing, particularly if we're testing a larger environment. Alrighty, so we talked a lot about Metasploit. Let's move a little bit beyond Metasploit though, because what we're really identifying here is that what made Metasploit so awesome is its focus on the vulnerability itself that we would maybe want to do something with. Is the exploitation necessary to be part of that process? I would posit no. Of course, Metasploit is an exploitation framework as well, so exploits themselves are a core component of it, but if we compare that to, say, a vulnerability scanner might not actually tell you, it might not actually give you the exploits, right? You might not use a vulnerability scanner to perform the exploit itself, whereas Metasploit you do that piece with. But I would also suggest this is maybe one of the reasons why Metasploit has fallen off a little bit, because our perception of Metasploit is that if there's no exploit within the framework to do the thing we want to do, we're going to go elsewhere. We don't look at Nmap and think about it the same way. We look at Nmap and we say, hey, Nmap, I want you to tell me the attack surface for this system, for this network, for this environment. I want you to show me the art of the possible. What services are listing? MS SQL? Maybe I can log into that. This is what our vulnerability scanners often provide. Now in this case, we're using Nmap scripting engine here real briefly, and we're using a script called Vulners. Has anyone here used Vulners before? Vulners has a bad rep, and it has a bad rep for a good reason. You see, what Vulners does is it uses something called Common Platform Enumeration, CPEs. So it basically scans a system, fingerprints what the version is of that piece of software, and then it looks it up in a database to see what vulnerabilities exist for that version of that piece of software. There's a number of reasons why this is not particularly useful information for us as penetration testers. Let's say that one of these vulnerabilities up here is about log4j. Okay, maybe that local system has a log4j package installed. Is the exploitation result possible? I don't know. We'll have to check that out. You see, one of the things about a lot of vulnerabilities, but log4j especially, is that log4j might be a vulnerability, but you still need to be able to do the JNDI injection. That means you need to have something in the application that accepts that processes it. And once it processes it, oh, well, yeah, it's over. But if it doesn't do that, if it doesn't care about logging, let's say log4j, then you're not vulnerable. Yeah, you might have the package installed, but it is not accessible by the attacker. And therefore, the exploitation result itself is not possible. And if we're looking at vulnerability scanning, and we think about things like software bill of materials scanning, CPE-based, ISO 27001, these are all very focused on that kind of thing. What do we call this in, say, the vulnerability assessment or management space? Prone to false positives. That's what we do. We call it prone to false positives. And this gets a little bit worse because Vulners spits out a lot of vulnerabilities list-wise pretty quickly. So for new folks to this who haven't actually experienced it not being very valuable information, you'll often get this false sense of security that you really are seeing the things that matter when in actuality, you very well might not be. That being said, this is just one Nmap script, and there are many other ways that we can go about doing this kind of thing. You see, Nmap scripting engine is a full application programming interface, library, etc., that allows us to very quickly build out vulnerability scanning scripts to identify issues. I find this particularly useful if we have found a novel issue inside of a client environment and we want to find out where else that is. You see, if you look at Nmap scripting engine in a more traditional sense, you might say, okay, log4j came out, so let me write a script for log4j. That's fine. I find that to be valuable. But as a penetration tester, I find that in most environments, I'm going to walk into something funky. It's weird. There's going to be some weird stuff going on, and I'm going to find some weird vulnerability, and I'm going to want to cross-validate that all over the place. Write a Python script for this? You could. But I would suggest that you may want to consider something like the Nmap scripting engine. So for example, let's take a look here real briefly at a very basic Lua script for Nmap scripting engine. Alrighty. So in the case of Nmap scripting engine, let me zoom this in here real quickly. There we go. There's basically three sections to any Nmap script, and I do have a slide for this. The head section, the rule section, and the action section, and those allow you to control different pieces around whether the scan runs or not against a given target in a lot of ways. And you can control all those things. So this is where it starts to be a little bit more performant, if you will, than let's say just an arbitrary Python script. Because I could just write a Python script that just checks everything every time. But what if we got 10,000 endpoints? What if we have 100,000 endpoints? These all have 65,000 ports. What are these things even running on? Can we build something that leverages a full underlying platform to determine when we want to hit something, send a script, or not? And Nmap absolutely has these kind of capabilities built into it. Let's take a look at a little bit more of an in-depth Nmap script here. This one is for log4j, or I should say log4shell. I find this to be an interesting example of vulnerability scanners in general as well, because it actually proves me to be a bit of a liar, right? I said these vulnerability scanners, they don't really do exploitation. But that's not actually true. You see, in order to identify a vulnerability, in a lot of situations, you have to do a bit of a guess and check style of test. That means I send the real exploit, and if it says, oh yeah, pwned, back at me, I know it's vulnerable. So in the case of vulnerability scanners, for many of these more in-depth modules that go beyond just version checking and then common platform enumeration, you'll see the actual exploit in the code of the vulnerability scanner itself. It's just not trying to then deliver Meterpreter after the fact. And log4j is exactly that way, because there's no way to scan a web application, for example, though it's not necessarily exclusively a web app vulnerability, but there's no way to scan a web app and have the web app tell you exactly what the version of Java is that it's running and exactly what all of the underlying packages are that are within that. If it did, we'd call that an information disclosure vulnerability because it lets us know what vulnerabilities might actually exist. So they don't do that, which means that our scanning module might need to be a little bit more in depth. And here we can see that you can import a bundle of different packages within Nmap scripting engine to make this easier so you don't have to reinvent the wheel in a lot of fashions. And finally, we can also see a little bit of exploitation here too, or technically exploitation, but really the scan. Okay, so that's a little bit of of Nmap scripting engine here, but there's a lot more to it than just this. You see, I'm lazy. I'm really, really lazy. And this looks helpful, but it also looks to me like work. Can we achieve that same level of scalability for the discovery of, let's say, novel vulnerabilities without having to write full-on code? Can we just identify what the parameters by which exploitation may be possible, and then have a scanning module that, let's say, uses a template to check those? And the answer is absolutely yes. In fact, these days, and this is a bit more of modern vulnerability scanning, vulnerability assessment, if you will, we have some significantly improved tools. And I don't want to say that Nmap is bad by any means, but Nmap scripting engine is heavy. And we don't always want to be leveraging a really heavy tool to do quick and dirty stuff at scale. I find Project Discovery to be absolutely outstanding for this purpose. Anyone here used Project Discovery before? Awesome. Yeah, Project Discovery is actually a big project with a number of different tools. I think there's 5 core ones to it. Maybe I can get this off the top of my head. Nuclei, that's their big vulnerability scanner. There is HTTPX, which is a really, really fast HTTP grabber, essentially, and it forms the backbone of a lot of what Nuclei also uses directly to identify vulnerabilities. There's Nabu, which is a Go-based scanner, quite a bit faster than Nmap. Sometimes. Nmap's a little weird, but there are faster ways to go about doing direct port scanning. Project Discovery has one called Nabu that's in it. I'm missing one. Oh well. In any case, a lot of really good tools here, but the one that stands out the most if we're talking about vulnerabilities is Nuclei. All of the other tools in Project Discovery are the backbone of what makes this possible, but Nuclei itself is the vulnerability scanner that you'll leverage in order to do tests. Here's what's really interesting. Remember that Nmap scripting engine script right here? So here we've got log4j. This is my only exploitation injection parameter. I'm specifically doing this into a header field for web, okay? If this header field doesn't exist for that web application, the web application could be vulnerable and this will not work. That's a false negative response. That's not ideal. That means that I probably would want to find out a bundle of these and create a big list and a bunch of different checks for each one of those to determine if any of the possibilities or any of the possible or common parameters are vulnerable to exploitation. Maybe. You see, what if this was a pen test I did for a very specific application inside of an environment? In that case, all of the other instances are likely going to be the same, so the specific parameter that I already know worked in my first part of the pen test is the only one that I want to repeat. That might be nice. Here's how easy this is to do in Project Discovery. Look at that. These are template-based scans. In fact, take a look at how many of these different parameters they decided to put into their template for these scans. I had one. This, I have to scroll through multiple pages, and this is a single vulnerability inside of Nuclei. What's really interesting about it, though, is that these are simply YAML parameters, and it's very easy to set them up. So, for example, if we look at Nmap again, here in Nmap, one of the things that makes it particularly handy is that if we want it to report that a vulnerability exists or not, we can actually tell it specific parameters to leverage. In this case, I have put this one in the vuln category. We can also say, hey, look, only send this module if the remote system and port is HTTP. That's interesting, isn't it? Because if we had, the potential for 65,000 different ports on a given system, but I'm using a scanning module that looks for log4j and HTTP, why would I send it 65,000 times? And why wouldn't I just check to see if it's HTTP first and then send it? This is one of the reasons why Nmap scripting engine is so powerful, because the underlying Nmap framework itself will handle that for you, and so does Project Discovery. It's just even easier. And here's an example of exactly how that might work. These are the generics, and here are the standards. Project Discovery, really, really powerful from this perspective as a result. And more importantly, I think this is the big core thing that makes this tool so fantastic. It's fast. It's really, really easy to just put something like this together real quick and then send it out to find the other 999 vulnerabilities inside of the environment where you've discovered the first one as a pen tester. And then you know what? Time to make 999 shells rain down from the sky. Alrighty. So that's Project Discovery, and I think that it really demonstrates a completely novel approach to identifying vulnerabilities and doing vulnerability scanning. If we compare it to some of the big 3 vulnerability scanners, right? Qualys, Tenable, and Rapid7, they take the NSE style approach. In fact, the Nessus attack scripting language, NASL, is a beast. Oh my gosh, that thing is crazy. And its sub-dependencies that exist within it, oh man. You need a PhD or an actual full-time job in order to be dealing with that. And that's true. That's why Tenable exists as an organization. Product discovery says, you know, that might be necessary in some cases, but for 80% of the cases, it's just not. And that's really, really powerful. Final scanning tool here to talk about is one called Sirius Scan. And I am the author of this scanning tool. It is an open source vulnerability scanner as well. I should have mentioned that as well, by the way. Let's talk about licensing. Yeah, so Nmap is licensed GPL, which means it's copyleft. Product discovery and nuclei, they're all licensed MIT, which means you can kind of reuse them in the nth degree of an open source style to your heart's content. And Sirius here is also an MIT product, so it is fully open source, and you can do whatever the heck you want with it. In any case, though, Sirius has actually been a passion project of mine for about 3 years now, and it has evolved a bit over time. You might notice that this maybe looks a little bit better than the version 1 or the version 2, but you know what? It's a decent vulnerability scanner in the end. Alrighty, let's talk about what it does. So the first thing to note here is that your database is key. Let's go all the way back to that Metasploit database part of the conversation. Your database is the thing that's important. And if you can control the data that is in there, and I mean the vulnerability data that's in there, you have a lot of power. You've got potential for automation of your report creation, in fact. And you know what? If I have to write less Word and spend fewer hours in Microsoft Excel and PowerPoint, oh, shoot, this is a PowerPoint, isn't it? Then I'm super happy, right? Absolutely. And so in this case, what we have is a fully open source vulnerability database. And this is something that both Product Discovery and Nmap fundamentally lack. And that's a really, really big problem. Because you see, if we do an Nmap scan and Vulners gives us a big list back of all the potential CVEs that might affect a system, well, it's just going to give us the CVEs. Now it's our job to start doing that research and figuring out how bad is this vulnerability actually. If we had a public vulnerability database with perhaps an open API that we can call, this problem becomes solved. Moreover, let's say that we tend to see some of the same vulnerabilities often. And perhaps as a penetration tester, I want to say, you know what? This SSH vulnerability that often is related to a bad password or maybe a virtual keyboard or something like that, that's typically listed as like a 5.4, I actually get a lot of value from it, and I want that to pop up at the top of my scans every single time it shows up. Can you do that in Nessus? Sort of. But in this case, you get to change your vulnerability data directly if you want to. Moreover, there are some issues with this approach. You see, why hasn't anyone done this before? Rapid7, Tenable, and Qualys have hundreds of engineers who spend a lot of their time documenting details about vulnerabilities. Because if you go to NIST, for example, you pull down the CVE record, that's going to give you a little bit of information about that vulnerability, but it's not going to give you a lot. And it's definitely not going to give you insight on how you might go about remediating it, what the chances and potential are that that vulnerability is a false positive. Is it being used actively in the field? Is it part of Metasploit? What does the vulnerability intelligence say? What about the KEVs? None of this information is in that data set. This is all manual research that we may have to do as penetration testers. And it is also exactly the intellectual property that has made the big three vulnerability scanning vendors essentially a soft monopoly in our space. But now we have AI and ChatGPT. So this here is an online tool called Vunerability-GPT. What it does is it starts with the CVE information from NIST, and then it uses that in order to create a ton of different prompts, which is then prompt engineers against artificial intelligence models to determine, and use a little bit of RAG as well with Google, to determine whether or not the information is legitimate, yes or no. And then based off of that, it will then also give you its insight on more detail about the vulnerability, insight about threat intelligence, insight about remediation, the threat model, all of those kinds of things, which it's kind of gee whiz information at first until you realize it needs to do this 40,000 times per year to keep up with Rapid7. That is difficult if you are Nmap, if you are product discovery, that is difficult for you to do. But AI, you know, we don't pay them by the hour, we just pay them by the electrical bill and NVIDIA bill. This also has a chatbot, so if you look at the very bottom of the screen here, the little chat-looking thing, you can click into that and you can ask it questions specifically about the vulnerability that you're inspecting. And since it's basically done all of the retrieval augmented generation required in order to have a big data set about the issue itself, this can be very helpful. I also find this can be pretty helpful if we're writing reports. Now, I know before you go, oh my gosh, this is sensitive information, don't put client data in an AI model. That's not what I'm talking about. Let's say a new vulnerability came out and you now have to, in your penetration testing report, write up that finding. This is work. Why do the work when you can just, outsource it to ChatGPT-ish, vulnerability GPT? And this is exactly what the vulnerability database within Sirius is based off of. So here you see a vulnerability scan that's been fully completed, and all of those findings, they're all associated with the results that came back from vulnerability GPT and were derived and generated ahead of the time. Fabulous. Now here's the real kicker, though, with Sirius Scan. I'm a penetration tester. I do a fair bit of vulnerability management and assessments. In fact, I was the author of the vulnerability assessment course at the SANS Institute for a while. So maybe I don't bleed as red as I think I do, or at least in my head canon that I believe that I do. But at the end of the day, I'm a pen tester first. I like offensive security, and I want my tools to give me control. I absolutely want that. You see, if Rapid7 gave me a scanner with an agent that allowed me arbitrary code execution and allowed me to execute access based off the vulnerabilities that the scanner itself discovered, I'm paying tons of money for that thing. That's amazing. I want that. But why would they do this? You see, if their utility is also an agent, suddenly they're a little concerned as a for-profit vendor that somebody like CrowdStrike is going to flag them as malware. So they have a direct disincentive to take that approach in the first place. And secondarily, penetration testers do not have very deep pockets. Oh, I'm sorry, everyone. Y'all be broke, boys. Yeah, if you compare that to the budget that a, let's say, Fortune 100 company has for their vulnerability scanning appliance, it's not even close. Like, Chase Bank probably pays Rapid7 more for their license than Rapid7 gets for entirety of Metasploit Pro. I don't think that that's even in question, to be honest, though it might be. Who knows? But the point is, they have a different customer base than penetration testers. They have a much higher level of individual that is evaluating those results. You see, if we're looking at a vulnerability management program, you start finding some vulnerabilities here, and then you're doing vulnerability data management against those actual issues, maybe a little bit of triage, but you're really just a project manager for the vulnerabilities at that point. Vulnerability assessment often gets caught up in that same weeds because we often think about it as the second step after VM, but it's not, or at least it should not be. If you're doing vulnerability assessment properly, you should not miss that MS-SQL login vulnerability. You shouldn't. Will Nessus find it? Probably not. In fact, almost guaranteed not, because Nessus is going to say, oh, this is a login opportunity. I don't want to lock out these accounts, so I'm not even going to try. But if you're a vulnerability assessor and you miss that vulnerability on a critical application in your environment, you are the problem. You are absolutely the problem. But unfortunately, the tools you use, Rapid7, Tenable, these kind of tools, are not making your life easier because they're not designed for tactical usage, for tactical operations. And that's exactly what Sirius Scan here is. In fact, I wouldn't even say that Sirius Scan is quintessential from this perspective. Nuclei is very much a tactical-based vulnerability scanner. That is what it's all about. This is not a set and forget, a run every month kind of scanner. This is a scanner that you build the way that you do tactical direct operations around and get a lot more efficient as a result of that. And that is exactly the intent of Sirius Scan as well, but with just a few more added components. So if you look here at the host view, for example, instead of the traditional, let's say, Rapid7 style, where it's just giving you the vulnerabilities and it's giving you remediation first kind of information, in this case, it's giving you exploitation next kind of information. We care about the services that are running on these systems. We care about the vulnerabilities that might be associated with those. We would really like to have some search capability within that as well. And so this is really focused on what you're going to do next exploitatively first. Now, what is Sirius from a scanning-based perspective? Because we're really talking about the UI and the database here for the most part. Sirius is a tool of tools, which is to say, does it use Nmap scripting engine? Yes, it does. It doesn't actually use Nmap for port scanning. It uses Rust Scan for that instead, a little bit faster. Can it use other things? Absolutely. There are two scanners built into Sirius directly, natively. They're Hunt and Howl. Those are template-based scanners as well. They're respectively agent-based template scans and network-based template scans. So if you look at Project Discovery, it is a network-based template scanning engine, particularly focused on web applications in a lot of cases. But the idea there is I can create a YAML template, I can send that sucker off, super duper easy. It's going to hit some node on the network and determine for me whether or not it is vulnerable, yes or no. Can we take that exact same ethos, that same methodology, and can we apply it to local system execution? 100%. If Project Discovery had an agent, it would do that. In the case of Sirius, that agent is Hunt. Howl is the network-based one. But Howl is very similar to Nuclei, just worse, honestly. Nuclei integration is actually in the future path for Sirius Scan. It is not actually part of the tool just yet, but it is absolutely part of the goal. Running a little time. Alrighty, and then there's a Sirius Scanner here. So this is an example of what the scan would actually look like while it's running live and in real time. This is also rather useful for us. A lot of our command line based scanners, when we trigger them, they don't give us the best real-time response value back. And as a penetration tester, I often like to run a tool and then start working through the output of that tool as the tool itself is working. And this is not something that many of our less robust but still really good tools have. In the case of Sirius, all of these are in the back end spun off as individual threads, and so you get a lot more live insight as well. Fantastic. That was actually perfect timing. We have 10 minutes left for questions, or 5 perhaps, actually. Alrighty, everyone. Thank you so much for listening to me. It was a great pleasure to have this conversation with you all here at Wild West. This is my favorite conference on the planet, and Sirius has been a work in progress and a passion project for me for 3 years now. So I'm very glad to finally see it right at the edge of rolling out. It's beta at the moment, so it is definitely usable, but there are still some bugs. Not gonna lie.